All right, good morning, everyone. I'm Laszlo Szűcs from the Leibniz Supercomputing Center from Germany, and I would like to update you on the activities at our site and the current status of DAOS. So for those who might not know where we are one of the three major supercomputing centers in Germany and located just a bit norther than Munich. Generally we are serving the Bavarian and German scientific community with data storage, general IT, and supercomputing resources. The projects, to gain computing resources at our supercomputers, one has to apply for computing time, and this goes through a pre-review process. We are serving about 2,000 researchers over the lifetime of the current supercomputing system that we have, and this involves hundreds of projects, mostly in astrophysics, particle physics, chemistry, material sciences, and fluid dynamics, as well as life sciences. And besides providing computing resources to scientists, we also help them port their codes to our systems and the emerging new resources like GPUs and for example, the DAOS system. So our current workhorse is the SuperMUC-NG. This is already a 5 years old system. Last time it ranked as 31st on the top 500 list, and this is a CPU only system. And with the phase 2 of the system, we would like to extend the capabilities and the services that we can offer to scientific users by adding GPU resources. And we are working currently with Lenovo and Intel to bring up the second phase of this system, which consists of 240 compute nodes, which are equipped with 2 Sapphire Rapids and 4 PVC GPUs. And probably we'll hear some performance metrics later today from this system. And so the main purpose for installing this phase 2 system of the SuperMUC-NG is to keep servicing or providing support for the traditional HPC users in simulations and modeling, but also to open up for high performance artificial intelligence and high performance data analytics workloads, and to research also the integration of AI and HPC workflows. So here are a bit more information about the hardware in this phase 2 system. For the current talk, the most important parts are the characteristics of the DAOS storage system. So this is a smaller system than Argon. We have 1 petabyte NVMe capacity and 38 terabyte persistent memory capacity. And with not the full configuration, we submitted IO 500 results earlier this year. And you will also see submission for later this week, which is a remarkable improvement on the previous results. And so besides the DAOS system, we will also integrate the GPS-fast file systems from the first phase of the supercomputer. And we provide also a so-called data science storage system as well. And so for comparison between the first phase and the second phase, yes, here's a slide. Okay, to go to more details about the hardware characteristics. So we have 42 DAOS servers, each with 16 PMEM memory, so about like 2 terabytes per node, and also yeah, NVMe storage. And they are equipped with 2 InfiniBand HDR200 network cards. So the single node performance are in the write in the 20 gigabytes per second, and the read is 40 gigabytes per second range. And besides these storage nodes, we also have a set of data mover nodes. These serve the purpose for transferring data between the DAOS system, which is directly connected to this new phase 2 compute architecture infrastructure, and the DSS and the GPFS storages, which are connected to the phase 1 system. And so we don't have too much experience with DAOS so far. The system was, so the compute nodes were delivered in autumn this year, and until like, well, basically last week, the system was mostly occupied by infrastructure works and the HPL measurements, and also the IO500 measurements. And we got access for our testing only like last week. On the other hand, we already encountered a couple of issues, some of them well, related to our so far lack of experience, I presume. So one issue is the with the network fabrics. So to utilize the RDMI capabilities of the PVC GPUs, we would need PSM3 fabrics, while the DAOS at the moment is optimized to work with the Mellanox fabrics provider. And this led to some issues. The other issues that we have seen were with the interception libraries, which are needed to achieve good performance on the POSIX containers. And we see, for example, when we try mixed GPFS and DAOS usage, that we see errors. There are also questions where to mount the DAOS containers the best, because due to some permissions, we also see some issues in file paths related to the GPFS storage system. And the third thing is that at the moment we don't see in user jobs very detailed log informations for failed jobs, and the DAOS logs live on the DAOS servers, and we are trying to figure out how the best to collect these logs and expose it to the support personnel. The system is expected to go to pilot phase early next year, so that means that we will invite some selected users to try out the compute nodes, and as well as the storage system. The main use cases will be AI and machine learning dataset storage. Then we have some long-term users at our sites which have IO-limited workloads, and they are interested in exploring the DAOS solution. And for the more traditional HPC applications, we selected a couple of use cases where, for example, HDF5 containers can be utilized directly. And from starting early next year, we will include also DAOS training in our scaling workshops for our systems users. And so as a summary, the system is delivered and the acceptance testing is ongoing. So far the performance metrics are very promising, and we are generally happy with what is delivered. But due to the relatively late delivery, we still lack the experience with the system. And you will see this Wednesday the IO 500 announcement. I think it looks very promising. And for those who are interested in the Ponte Vecchio experience, then there will be a session later this afternoon at the same place. You are welcome to come. We have a bit more benchmarks to show there. And with that, thank you for your attention, and please feel free to ask questions. Yes?
Just a really quick comment on the log collection. So starting with 2.4, we actually have a log collection tool available in DAOS. I didn't talk about it, I apologize. So you will be able to easily collect the logs from all the servers selected, whatever. The tool will continue improving based on the feedback we received from Google and from other partners. So, but you're welcome to use it.
Great, thank you. We are looking forward to.
Question on the interception library. Did you use the new Pil4DFS library or the older one, libIO? Do you know?
I'm not sure.
Okay.
Yes, this was. I was already traveling when my colleague did this test last week.
Yeah.
So
let's take it offline. Yeah, it would be interesting to find which one of the two libraries you used. There is an older one and there is a newer one. So.
Yes, I will find out and get back to you.
Just a quick question. Ethan Brand at Google. Thanks to you and Kevin for the IO 500 submissions as well. I saw that your clients had 2 Meltdocs NICs. Is that right?
Yes.
Are you making use of both of them, or how are you?
Yes. Yes. Perhaps Michael could add more information on that.
Yeah, so on the server, we have one engine per NIC, right? On the client, we use HWLock to find the NUMA structure of the node. And the process will always talk to the NIC that's local. So if you have one MPI task, you use one NIC.
Nice.
But if you have 2 or more, you use both NICs.
Do they all need to be on the same IP space then? Or?
Yes.
Yeah.
And the number one issue configuring a DAOS client-side cluster is that you get something wrong there. You get an APP request on one interface and a response on the other. So there's documentation on the website how to avoid that, but still it's very easy to shoot yourself in the foot. And everybody does.
Yeah. No, it's great that at least